Resin material is fed to the injection barrel from the hopper. These hoppers may be filled manually or vacuum-fed automatically, and often have dryers attached to the top to remove the moisture from the material. As the resin enters the injection barrel, it is driven forward by the rotation of the screw, which is powered by the hydraulic motor. The resin plasticizes or melts as the turning screw drags it towards the nozzle end. This is referred to as drag flow. Drag flow causes the polymer molecules to slide over each other, creating frictional heat, which melts the material. External heating bands provide additional heat to the injection barrel. The heating bands bring the material to its final temperature and compensate for the radiation heat loss. The temperature is controlled by 3 thermocouples in the barrel and 1 in the nozzle.
Most extruder head and die assemblies are classified as the crosshead type, which diverts the melt flow 90 degrees from a horizontal to a vertical orientation. 2 kinds of crosshead die assemblies are most commonly used in extrusion blow molding: the center feed and the side feed assembly. The center feed assembly produces a fairly uniform melt by forcing it to flow vertically downward around the tip of a conical torpedo-shaped core called a mandrel or pin. This results in straight flow all around the mandrel. In the side feed assembly, the melted resin is forced around the perimeter of the mandrel, allowing the melt to flow uniformly down around the mandrel and then extruded through the die as a parison. The die consists of a mandrel and a bushing, which are designed to produce a parison of the desired wall thickness. There are 2 primary types of die tooling: converging, which flares inward, and diverging, which flares outward. Thermoforming molds provide the shape to which the plastic sheet conforms to produce a thermoformed part. Typically, thermoforming molds have protruded or convex surfaces and are referred to as male or positive molds, or concave cavity surfaces and are referred to as female or negative molds. Thermoforming molds are produced from a wide variety of materials, depending on the products being produced and the annual volume of products required. For short runs, prototypes, and one-of-a-kind forming, inexpensive materials such as wood, epoxy, plaster, and urethane are commonly utilized. These molds are not temperature controlled. For high-volume production runs, temperature-controlled molds produced from aluminum are always used. Aluminum is the ideal metal for thermoforming molds because of its light weight, machinability, and high rate of heat transfer. blown film extrusion process uses an extruder to pump molten plastic vertically up through a die having a 360-degree annular opening on its top. This produces a tubular film extrusion, which is subsequently filled with air. As a result, the tube expands out into a bubble, having a diameter larger than the diameter of the annular opening of the die. The tubular bubble cools as it is pulled up. When sufficiently cooled, the bubble is flattened within a collapsing frame. The flattened plastic is then pulled through a series of rolls, commonly referred to as nip rolls. Nip rolls help to maintain tension on the flattened plastic film as it is guided to a winder and wound onto a core for later use. Since frictional heat does not dissipate easily through a plastic workpiece, the part surface finish may be affected if it's allowed to reach the softening point. Excessive heat buildup can also dull the cutting tool. For these reasons, the use of coolant may be required to reduce frictional heat. Typical coolants used for machining plastics include clean compressed air, which aids in chip removal and limits part contamination, and the use of mist sprays, water-soluble oils, light cutting oils, and other solutions for use in high-speed and automatic operations. Coolant must be selected with care, as some may react with certain plastic materials.